Okay, so now let's talk about probability histograms. So this the next assignment is to construct a probability histogram for random variable u. By the way, here it is. In a previous video, it was conflicting. There was u here and v there, so I corrected it all to u. So be aware of it. And so this is what we're gonna create a histogram of. These are our values for our random variable, and it goes on the onto the x-axis. Now onto the y-axis, we're gonna put the probabilities. So here we have our basis for a histogram. We have on the x-axis of values for variable u, which is the number of heads in the 3 tosses of a fair coin. And we also have probabilities listed. So the highest probability that we have to actually picture is 3/8. So we have 1/8 and 3/8. So that's I have 3 tick marks here. This is going to be 1/8, 2/8, and 3/8 is the highest mark. Now let me actually remind you that we're dealing with a discrete variable. So the width of each histogram of each bar for the histogram is going to be the width between our variables. So the first one is 0, then 1, then 2, then 3, then 4, and the bar goes from the, it includes the left endpoints and it extends to the one on the right, but it actually does not include the right endpoint. All right, so the probability for 0 was 1/8. So it's going to extend up until 1. Then after 1, we have the probability of 3/8. So this bar is going to come up all the way to 3/8. Okay, and the next one is going to come up until 3/8 as well. So here we go. And again, it extends until the point on the right, but not including it. And the last one for 3, it includes 3. And it's 1/8, but it's not including the 4. Okay, so this is our histogram. And here I wanted to draw your attention to one interesting fact. Let me ask you this question. What's the area of shaded rectangles? Well, let's calculate, right? Calculating the formula for calculating the area of a rectangle is length times width. So the length of each rectangle would be 1, and what's the width or the height of it is the probability, right? So right here we have 1 times the probability of 0, which is 1/8. Here we're going to have 1 times the height, which is the probability of 1. It's going to be 3/8. Here we have 1 times 3/8 and 1 times 1/8. So when we add them up, what are we going to get? We're going to get 1/8 plus 3/8 plus 3/8 plus 1/8, and that's going to be equal to 1. So this all shaded area here equals to 1. This is a very important fact that we're going to be using later on, so keep it in the back of your mind. So our next example is constructing a probability histogram for W. Let's recall again, this is our variable W. The values there are possible values there are 0, 1, 2. and the corresponding probabilities, and now we have to draw them up. So again, we're gonna our axis is gonna represent W, and the y-axis is gonna represent probability of W. So here we are, we have x-axis, that's our W, or the number of heads out of 2 tosses, and y is the probability of W. Have 0, 1, 2, and 3. All right, so the first probability is 4/9, the second is 4/9, and we also have 1/9. So here we go. This is what our histogram is going to look like. We have 3 bars. And what if we wanted to calculate the area of those bars? So again, just like with the previous example, the width of each bar is 1. So we're going to 1 times the height, and the height is the probability, right? 4/9 plus this is also 1 times 4/9 plus 1 times 1/9. So we're going to have 4/9 and 4/9 and 1/9. That gives us 9/9 and is 1. So the total area is 1, which is the same as our total probabilities. So from here, we can we already have a sense of the fact that the probability actually is represented by the areas of those bars, right? So the areas and the of the bars and the probabilities are going to be the same thing. And we're going to use it in our future calculations. So here's our next example. We have a probability distribution histogram, which represents hours spent playing video games on weekends. And we have values from 0 to 4, including 4, but not including 5, right? And what we need to do is construct the probability distribution table using the histogram. So in other words, to recreate the table from which this histogram was created. Can we do that? And the answer is, of course, yes. Can we, do we know what the X values were? Yes. It's 0, 1, 2, 3, and 4, as we already mentioned. 5 is not included. The right end is not included. So we're going to call it xi because it's like the first x, the second x. So that's what I is for. That's a counter. So what's the probability of each of those outcomes? Well, we have to calculate the area of each rectangle, right? So the width is 1 and the height is 0.08. So that probability is 0.08. Now, what about 2? The 1, the probability that the person spent 1 hour playing video games. Again, the width of a rectangle is 1 and the height is 0.12. So that probability is 0.12. For 2 hours, again, it's 1 times 0.16. So that's the probability is 0.16. For the next one, that for 3 hours is going to be 0.28. And for 4 hours is going to be 0.36. Okay, and I believe that if we add all of these together, we're going to get our probability 1 equals to 1.